Today's class we'll go ahead with the normal forms, right? But before that, we'll just review what we have seen in the earlier classes. Earlier classes, we were talking about grammar. Now, this would be T. And then you had certain rules of the grammar based on which we divided the grammar into regular grammar and certain things as context-free grammar. Now, in context-free grammar, you will have a set of, we will have a set of productions which will be of the form x produces y. Now this x will be belonging to the variable which will have only one symbol, and the length of the left hand side would be always equal to 1. On to the right hand side, you will have v union t the whole closure. What is v union t? The set of variables union the set of terminals or the symbols from your alphabet, the whole closure. So this is how it works about. And then you have a set of protections. Now, once this is done, we talked about, hope you remember, we talked about derivation. Now, what is derivation all about? Given a string or a word, starting from the starting symbol of the grammar, try to replace it with the respective or the appropriate right hand side of the alternate production, where you, at the end, you'll be able to receive a sequence of terminals which you call it as a sentence. Now, the derivation can be divided into two. One is leftmost derivation and the other one is rightmost derivation. Leftmost derivation, whenever you have more than more than one variable to be substituted, try to always choose the leftmost one. You call it as leftmost derivation. If you are choosing the rightmost one for a substitution, you call it as rightmost derivation. And the intermediate forms, whatever is generated by the leftmost derivation, you call it as the left sentential form. And the one which is generated by the rightmost derivation, you call it as the right sentential form. The other name for rightmost derivation is canonical derivation. Now we also have one more way of processing the sentence. The second way of processing the sentence is based on reduction. Reduction, what you do, you try to start from the sentence, not from the starting symbol of the grammar, but then we try to start it from the sentence. And once you start it from the sentence, we'll search for appropriate string which occurs as the right hand side of any of the production. Try to replace it with the left hand side. Successfully, repeatedly do this until you reach the starting symbol of the grammar. Now, what happens is, how do I really find out what is the next step? You use the rightmost derivation, right? The reverse form of rightmost derivation is your reduction, and therefore, the reverse of canonical derivation or your rightmost derivation becomes your reduction part. And after discussing all this, we also talked about representing them in terms of an parse tree. And for a given sentence, for a given grammar, if I could generate either two leftmost derivations or two rightmost derivation or two parse tree, then you call the grammar to be an ambiguous grammar. And that is what is said here. A grammar G is ambiguous if there is at least one string. It need not, all the strings need not satisfy the constraint. But then if you are able to try out at least one string, or if you are able to conclude that at least one string can produce more than one parse tree, then you call it as the ambiguous grammar. And therefore you have a set of grammar where your R is equal to this particular thing. This is your language. And then R is equal to this particular thing. You have a given string here. So what they do is your production or your rule. R here means the production or the rule. S produces S's with S within parentheses and epsilon. If you see here, you have two different ways of doing it. The first one, they give it as S and S, and then they move forward. Now here the single S has been, this part is different. Here they have given with two S and then moved forward. Then in this case, they have substituted one S with the second alternative and moved forward. Now what happens? You have two different ways of substitution. And therefore, we call the grammar to be an ambiguous grammar. Fine. This is all about the ambiguity. Last class, we took an example of E produces E plus E, E star A and ID. This time, we'll take the explanation of uh, S produces S's or S within parenthesis or epsilon. So this grammar is also ambiguous. Moving forward, we'll go in for something called a simplification of a grammar. We have four major ways of simplifying a given grammar. And once you try to simplify it, then we move in for the normal forms. So today's class will first concentrate on how you simplify in grammar. Once we simplify in grammar using the four main concepts, then you say among four you will use only three. One is wherever you can do it, you go ahead with it. Fine. So we'll apply all those three transformations of simplifying the grammar. Once we have done it, then we'll move in for converting into two different normal forms. So we'll take them one by one. Now you have something called as a substitution rule. Now what is substitution rule? Try to replace a variable by the right hand side of its production is substitution rule. Now we'll go ahead. We'll first try to take few examples and then we'll go ahead with this example. Right? Suppose you have S produces AA or BB, and then we'll say BA produces now you have such a the way where you represent three different productions for a given grammar. Now what can happen is A has two different alternatives, but if you see here B has only one alternative. So now the way of doing, you don't have any hard and fast rules in substitution. So what you do, wherever I have seen B, I can replace it with the right hand side of the production. So you rewrite the same thing, we'll also use an B here, right? So we'll replace the same, wherever you have B, we'll replace it with C. So I'll replace this B with C, I'll replace this B with C. And now this is not required. You can always delete it. Now the reason why we are deleting it, I'll tell you later, because nowhere on the right hand side of the set of productions I have B here. So now what happens? This is what you call it as substitution rule. This is what we call it as replacement. Fine. I can always replace these two productions in terms of A. So if I am further going in for replacing in terms of A, it becomes S produces. You have already an A with two A's and a B. This is the first option of A. The second option of A is A, B, C, B. And then we'll go ahead with the third option, it is B, C. So now what has happened? I have deleted this also, because nowhere I'm using the non-terminal A, it's just listing it. So now what happened? You can replace the right hand side of a production in terms of a variable, which you call it as a substitution. And that is what is being done here. You consider a given grammar where you have the set of variables A and B, the set of terminals sigma, instead of giving it as sigma A, B and C, we have defined it as A, B and C directly here. And the starting symbol of the grammar is A, set of productions what you have. Now what happens here is you have a set of productions where in the next case your A, B, they haven't still replaced this B, okay? But then what happens is you can replace this B with the A's option. So what has happened? It is AB with ABBA. That is what is given here. AB with ABBA and the last one is C. Similarly, you have an B here. So it is AB with the B, what instead of this capital B, and the small one is C. So this is what you call it as substitution. Now for this type of substitution rule, what questions can be asked is where you can have these two. You have two grammars. This grammar we'll take it as G1. This grammar we'll take it as G2. Now what happens? You have two different grammars and you are asked to show that these two grammars are equivalent. One way of doing it is you have to generate as many language, all these strings which both the grammars can generate. And then you say, since this grammar can generate 10 strings, and the same next grammar G2 can also generate only the same 10 strings, then you say that these two grammars are equivalent. Okay, I'll repeat it. When can you say the grammars are equivalent? Technically speaking, the language generated by G1 and the language generated by G2 has to be same. Only then G1 and G2 are equivalent. Now, what do you mean by the language generated by G1 and the language generated by G2? The set of all strings which can be generated by G1 should be equal to the set of strings which are generated by G2. There should not be any addition, any subtraction from the strings what you have generated. In that case, both grammars are equivalent. Now I can also do it in a different format. I can apply substitution rule, either convert G1 to G2 or G2 to G1 and show that they are equivalent. Now in this case, if you see, this production B is missing from your G1. So wherever I have B, let me replace it by the B's production. So what you can do is you can use your substitution rule, or you can say by applying the substitution rule, your G1 is written as, you say your S produces ABA and then B's option. The first option is AA. B has two options. So I'll go ahead with the first option, ABA. And the second option is BB. So now what has happened? And then you have the third alternative, the second alternative of S, which doesn't have B in it. So I'll write it. Now the first production of G1, where you have substituted B, is similar to what the first production of G2. Fine. What about the second production of G1? Second production of G1 is same as second production of G2. What about B? B is now nowhere used on the right hand side of your grammar. Instead of B, you have replaced it by the right hand side of B. It is nowhere used and therefore you are comfortably removing it. And hence G1 and G2 are same. You can reach a particular variable only from the starting symbol of the grammar. Until and unless you cannot connect it from the starting symbol, that particular variable is an useless variable, which we will be discussing it in another few minutes. Fine, and therefore G1 and G2 are equivalent. So what is substitution? Substitution is you try to replace a variable by its right hand side of the production, right? And rewrite it in some format. You can always go ahead for asking whether two grammars are equivalent. How do I find it? I apply the substitution rule, because generating all the strings and saying G1 generates 10 strings and G2 generates 10 strings, both the strings are equal, is highly impossible, because it's not the 10 strings what you generate, it is n strings which can be generated, which is highly impossible. And therefore, what you do is you try to use the substitution rule, rearrange the grammar and find out whether these two grammars represent the same language. Now, if you have any clarifications on this, you can ask me, or else you can say, you can just put it on the chat box to proceed further. Do you have any clarifications? Yes or no? If you don't have any clarifications, at least put proceed. Okay. So we'll go ahead with the next one. Where are we? Yeah. The next simplification, the first simplification is using the substitution rule. The second simplification is using the null production. Now, in order to understand what is null production, any production which is capable of generating an empty string or any variable which is capable of generating an empty string is called as a null variable. Fine, I'll repeat. Any variable which is capable of generating an empty string is a null variable. Fine. So now, having said that, if you take this particular case, this particular slide, you say X produces A produces epsilon. Now, which is a null variable? A produces epsilon. A directly produces epsilon, the empty string, and therefore A is a null variable. But what about X? X produces A, which indirectly produces the empty string, and therefore X is also nullable. So you just find these set of variables which can generate an empty string. That is your first step. Fine. So now what happens here? When I say A produces epsilon or A produces lambda, you say whenever you have a variable which produces a lambda function, lambda or an epsilon, you call that variable to be a nullable variable, and therefore A is nullable. Now, if in this case, in this example, what happens is X produces A. Is X nullable? No, in the first sense. But then A produces epsilon, which means A is nullable. And X produces A, therefore X is also nullable. Moving further, you have another set of information here. S produces A, C, A. Now what happens? C produces epsilon. And therefore, C becomes nullable. What happens to B? B produces B, C or C. Now it is an indirect connectivity saying B produces C, which is capable of generating an empty string, and therefore B is also nullable. What about A? C is nullable, B is nullable. A has some production saying A produces B, and therefore A, B, and C are nullable. Fine. Now let me give you an option saying, where are we? I'll give you a production saying A produces A, B, or A, and then B produces B or epsilon. Now tell me which of the following productions are nullable, which of the following variables are nullable. I'll put it onto the chat box. Okay, so now you have an option saying A produces A, B, or A, and then you have one more production saying B produces B or epsilon. Epsilon, I'll put it as E onto the chat box. Now for the given production, tell me which of the variables are nullable. You have three options. B is nullable, A is nullable, A and B are nullable. Can you put it onto the chat box, please? Or both the variables are not nullable. So the first option is B, first option is A, second option is B, third option is both A and B. I'll put it in this way. First option is A, second option is B, third option is both, and the fourth option is none among A and B. Now you can give me any one of the options. Which one is nullable? Either A or B or both are not nullable. Okay, I have received one answer. Can I have more answers from your side, please? Okay, I have three people answering the question. What about the others? Three, four have answered the question. Five. Okay. The silent listeners of the class, can you please respond? Abel, can I have your answers, please? Abel, Anit, Amit, Angel, and Ashish, I think you have responded. Rohit and Bharat have responded. Celsia, Divina, Emmanuel, can I have your response, please? Godwin, James. James, are you there in the class?
Yes, ma'am.
Okay. Can I have your response, please? கேர்ள்ஸே இல்லை போல கிளாஸ்ல அப்போ கேர்ள்ஸ் எல்லாரையும் ஆப்சன்ட் போட்டுடலாம்னு நினைக்கிறேன். Is it so? I have response only from the boys. Can I mark all girls to be absent for today? I thought girls were very good students. They used to respond actively and actively participate in the class. Am I right? Girls, பேரை கூப்பிட்டாலும் போட மாட்டோம். Okay, fine. Thank you, ma. Good. Now the question is, now all these questions were thrown to you not to put you face onto shame, just to make you understand. Thank you for your response. Okay, so we'll go ahead with the answer. There were two answers which I expected, and that is why I gave you the question. The first answer was B. Those who are given the second option, knowingly or unknowingly, it is the right option. Okay, your B produces epsilon. But what about A? Some of you have given both A and B produces epsilon. Now, the reason why I haven't chosen A is that when I substitute A's by A, it is A produces AB with A, right? So now what happens when I substitute B's value here, I'll have two options. One is it is AB, the other one is with A with epsilon. What is A with epsilon? A concatenated with epsilon is always an A. And the next one is A itself. So you'll have two A's, we'll again substitute it. Now what happens? Because you have some other variable or some other character associated with B, this A has escaped from being an, what to say, nullable variable. Now I'll give you one more option. Okay. Now the question is, I'll give you next case where A produces A or BC, right? B produces B or epsilon, and C produces C or epsilon. Now tell me which are the variables are nullable. A produces A or BC, B produces B or epsilon, C produces C or epsilon. Now which are the variables which you feel that they are nullable? B and C or A, B and C. You have only two options. The first option is BC. The second option is ABC. All the variables are nullable. Okay. Can I have those who haven't responded so far in my class? Can you respond? I hope you people do a lot of meditation, right? Once you log into the class, you go into a meditating mode. Okay. So what was my question? Now, question I have to figure it out. Can I have few more answers, please? Can I have few more answers, please? We'll call the names. Genovin. Jaranus, sorry here. Jaranus Moses, can you please respond?
Yes, ma'am.
You can put your answers onto the chat box.
Yes, ma'am.
Umaresan, Naveen, once I call you and you don't respond either by onto the chat box, you will be marked absent. Yes, ma'am. Chartered as Kuruga Solla Tambi. You're supposed to respond the first option or the second option. Surya Prakash.
Yes, ma'am.
Now you respond whether you are giving the first option or the second option.
Okay, ma'am.
Okay. Invariably, your answer was 1, except Bensam who got it for 2. Is there any way you can refute your answers? Anyone who has given already option 1, do you think your option is 2? Now here your option is, I think Bensam got it right. Your answer is 2. The reason is, I'll give you different options of substitution here. Will A produces A, we'll not talk about this. The problem with this was B and C. You have 2 options for B and C, which will give you totally 4 options, right? Now I put all those 2 options, 4 options, and tell you how it works out. B produces B, whereas C produces epsilon. You will have an answer to it. The second option is C produces, okay, B produces epsilon, where you won't get anything. C produces small c, you have the third option, second option. The last option is, sorry, the third option is B produces B, C produces C. That is your third option. The last option is B produces C, B produces epsilon, and C also produces epsilon. And therefore, the answer is 2. Your both A, B, and C are nullable. Do you have any clarifications? Should I explain it again? Do you need an explanation again? Either put it as repeat or give it as proceed onto the chat box. Okay. So now the option is, in this, we'll take the first case, the previous case. The previous case, you have 2 options for B here, B and epsilon. When I substituted B and epsilon in A, we never got an epsilon here. But then in this case, you have B and C, which produces B or epsilon or C or epsilon. Now what happens when you say B produces, there are 4 combinations. What can be the 4 combination? B can produce small b, whereas C can produce epsilon. Okay. Now B can produce epsilon, whereas C can produce the small c. The third option, the next option is B can produce B, the first alternative, C can produce C, the first alternative. The last option is both B and C can produce epsilon. Epsilon concatenated with epsilon is again an epsilon. So what happens now? A has a possibility of generating an epsilon. Fine. It's not that every time A should generate an epsilon, but A has a possibility of generating an epsilon, and therefore A is termed as a nullable variable. Whereas in the previous case, A never had a possibility of generating epsilon, and therefore A is not considered as a nullable variable. Is it clear? Can I proceed further? Can I proceed? Or should I repeat it again? Can I proceed or repeat? Give me the options, please. Okay, thank you. So now moving forward, you have a set of nullable variables. Now if we take this case, uh, you have options here. C produces epsilon, so C is nullable. Okay. B produces C, so B becomes nullable. A produces B, it is nullable, whereas S is not nullable. Therefore, nullable variables are A, B, and C. Now we'll move on to removing the nullable variables. So what I'll do is, we'll take a simple example and then we'll move forward. 1 second. Just hold on, I'll be back and repeat the explanation. Okay, I'll repeat it. Wait for another 2 minutes. Fine. So now for Harshit, those you can go ahead with the substitution rule. Okay. Whenever you find epsilon, try to substitute that variable with epsilon in the other productions. And if that production will generate an empty string, then you call it as a nullable variable. Somehow we'll take the same explanation again. Fine. So we'll just you hold on. You can A produces AA or AB. Now we'll say B produces epsilon, right? B produces epsilon or B produces epsilon. Now this is your first option. Now what we'll do, whenever I have such information, the first step is to find the nullable variable or the null variables. Now I'll put it as null variables. Now in this case, the null variable is B alone. So what we'll do, wherever you find B, replace it by epsilon. So what happens, the same set of production, you can convert it as S produces A and A produces A with epsilon. What is A with epsilon? A with epsilon is A alone. Fine. Now, if you see here, this way the production which produces epsilon is a null production which can be removed. I am just striking it off because there is no job of B here, and therefore we will comfortably remove B. This is a simple case of removing the null production. Okay. So now I will repeat it again. We'll identify the null variable. In this example, your null variable is B alone because B produces epsilon. When you put it here, your A will always produce an A, it's not an epsilon. It's A concatenated with epsilon, which is A, and therefore a null variable will not be generated. And the null variable is B here. So what is our aim? Our aim is to remove the null variable B. So, or the production saying B produces epsilon. That is our idea. So, whenever you have something which produces epsilon, remove it. Okay. So, what happens instead of, in order to remove B produces epsilon, I have to substitute the value of B wherever it occurs on the other production. So, this B here is being replaced. The B, whatever you had here, is being replaced with an epsilon. When you concatenate A with epsilon, it becomes Joel, yes, ma'am. Joel, is there any need? You have raised your hand. Mahane, விளையாடிட்டு இருக்கியா? Okay. So now what has happened? We have deleted this E, that is epsilon. What happens here is A produces AA or A. And then you have B produces epsilon, which is being deleted. This is your case 1. I think this you will all be able to understand. Now I'll do a little bit of modification here. Right? My modification here is I am adding one more concept here, one more production here. When you say it is B production, B or epsilon, this is similar to B produces B or B produces epsilon. That is what we are meaning. Because the left hand side is same, we have combined it together. So if that is the case, what am I supposed to do? I can always go ahead saying A produces AA. Then now your case is only when I have to do the substitution only when B produces epsilon. When B produces epsilon, what happens? Your AB will become A alone, right? When A has not produced, B has not produced epsilon, it has to produce B. So now what we'll do, when B produces epsilon, this first production has been converted to A produces AA or A. So now we'll rewrite it, okay? When I rewrite it, I'll combine it as A produces AA or A or AB. Why do I have AB here? Because when AB doesn't produce epsilon, it produces something else. And therefore, I have an AB here. And then we'll comfortably remove the epsilon, we'll retain the other thing. So it is A produces AA or AB or A or and B produces B. B produces epsilon has been comfortably removed. Fine. Now we'll go on to what we have in the presentation. So now you have all these informations. What happens when you go ahead with this? You have C produces epsilon. So what I'll do is, if C is epsilon, I'll go ahead step by step. You have different options. You know the nullable variables are A, B, and C. Now I'll give you all the options. Only when A is nullable, you have to see what are the productions you generate. When B is nullable, you have to take account of the things what is being generated. When C becomes nullable, you have to say what C generates. When AB is nullable, when BC is nullable, when AC is nullable, and when all the three are nullable. So I will give the options first. The first one is when if C is nullable, wherever I have C on the right hand side, I'll make it as epsilon. Okay, and you have all the things here. Now the next condition is when B is nullable, you have B on the right hand side of A in A's production alone. So that alone I have converted it to epsilon. The other things I have kept it as such. When A is nullable, A comes here. So that alone will haven't changed. When A is nullable, the first production alone hasn't changed. The rest remains. Now we'll go for the next option. If A and C are nullable, A and B are nullable, what happens? This A becomes epsilon, this B becomes epsilon, right? And you have only C. B is epsilon, B is nullable. So I have removed the A variable, B variable, and I have retained other things. When A and C are nullable, what happens? A variable I have removed, C I have removed, C I haven't removed because C has one more option. If you want, you can retain it or else you can remove. Now the last one is when C and B and epsilon are nullable, and the last one would be A, B, C and epsilon are nullable. Fine. Or the easy way of doing it is, I'll just put it in another way. So it would be easy for you. Now, previous slide, we know that A, B, and C are nullable. So now how will I do it? It's very simple. I'll do some changes to these slides, to all the informations here. You can have any options. So I'll write the additional options over here. When A, C are not nullable, okay, this option holds true because everywhere you look at, you have an option, other alternative apart from A produces epsilon or B produces epsilon and C produces epsilon. So if A is nullable, I'll have A, C, A. If C alone is nullable, I'll have A, and A. Now, what about both A and C are nullable? There is always an option for that. So it is, you'll have A. Now, what about this one? You are not going to do much of the changes here. We'll just delete this part alone. Fine, because if B is nullable, you will have an epsilon here. If B is not nullable, because you always have an option here, so it retains. Now C is not nullable, these two gets cancelled. When C is nullable, you put this, and also you can go in for small c. Because when C is nullable, this becomes epsilon, so you'll have an C here. So this is how you arrive at the answer. I'll leave both the options to you. I'll repeat it again in the next class. If you have any clarifications, you can ask me. I'll just give you the attendance. I've sent the attendance link. You can give me the response and leave the meet. Your attendance link will be closed.